Hi, welcome back. Today we'll be trying to solve today's LeetCode challenge problem, which is max sum of a pair with equal sum of digits. So you're given an array nums of only positive integers, and you can choose two indices I and j such that they're not the same element, and the sum of the digits of the number is equal for nums I and nums j. And we need to return the maximum value of nums I plus nums j. What this question means is, let's try to use a test case right here. So this part right here, which is the sums of the digit of the number, what it means is, for example here, 18 is going to be 1 plus 8, and then 43 is going to be 4 plus 3, and so on. And if we try to keep track of the result, it's gonna be 9, 7, 9, 4, and 7. We can see that the one that has the equal number sum of digits is the first and the third element, as well as the second and the last element. But in this test case here, we can see that the first and the third element pairing has the higher number than the second and the last, so it is being chosen. And let's head to the code. One of the ways to solve this is to keep track of all sum of digits, all elements that results to the same of sum of digits, which we can do by storing it in the hash map of list, which is the okay, let me try to code it first. So map integer array list integer list equals to new hash map. So we are going to store the key as the sum of digits, and array list as the list of the real number itself, which, for example, in this case, if we have 18, then 1 plus 8 is going to be 9, and we're going to store 9 here, and the list is we are going to append 18 to this array list right here. First of all, we need to iterate every element in the nums array such that we calculate everything and store it in this hash map based on what I explained previously. So for in oops. So what we are going to do first is we are going to create a new variable to store nums I, and there is a reason for this. And then we are going to create a sum for us to calculate each sum of the digits. And in order for us to do that, there is actually a way. So we are going to use modulus and division in order to achieve that. So while number is larger than 0, first of all, let's say in the case of 18, we can first try to get the modulus. Let's say 18 modulus 10, which is equals to 8. And then in order for us to move forward to get the one digit, the number 1 right here, we can do it by 18 divided by 10, which is equals to 1. So in code, it's gonna look like sum. We are going to append it with the modulus 1. So number modulus 10. Then we are going to divide the number with 10 by itself until the number reaches 0. So here we want to check if the map contains the key, because if it doesn't contain the key, that means we need to initialize a new array list. So if it doesn't contains the key, which in this case is the sum, so we need to initialize a new array list as mentioned previously. Let's put sum new array list integer, and then we are going to get the value, which is sum, and then append it to the array list. Now that we are done with this part, there's a second part where we calculate each possible pairing of the array list of integer. And one way to think about this is we can calculate every single possible pairing that can be found in this array list. So let's say if the array list, let's say one of the key of the array list is 7, and then the array list itself is, let me think, 43, and then 52 and 133. Let's say this is as an example. So basically we are going to count 43 plus 52, and then 43 plus 133, and then 52 plus 133, and then we get the largest, right? It is fine for a small size of array list, but once we get a much bigger size of array list, we don't want to do that, right? Because there's gonna be a lot of pairing. And if we go back to the question, it says to just find the max sum. So instead of us calculating every single pairing, we can just sort this, and coincidentally this has been sorted. So we can just sort this, and we can just add the last two number. Because if it's sorted, then we can be sure that the last element is going to be largest, and the second last element is going to be the second largest. And we are going to do that on the second part right here. So we are going to iterate the map, which is in, and we are going to keep track of the maximum number. So for map entry integer list integer and then list entry set, we want to make sure that we only find a pair if the size of the array list is more than 1, because there is this restriction right here where we cannot choose the number from the same indices. So if entry get value dot size is larger than 1, then we are going to sort the array list. So collections sort entry get value. After this, we are going to keep track of the largest element, the largest index, and the second largest index, which can be done by in largest index equals to entry get value size minus 1, and that means the second largest index is gonna be minus 2. entry get value -2. And then we want to get the number of the largest and the second largest number, obviously. So in largest number equals to entry get value get largest index. And we do the same for the second largest num. So entry get value get second largest index. And we are just trying to compare the current max value with the result of the sum between the largest num and the second largest num. So equals to math.max of the max variable by itself and also the largest num to the second largest num. And we want to return the max. Oh, there's something wrong with this. Oh yeah. Give me a second. Oh, here? I made a mistake here. So basically, I shouldn't have return number. So why is this the case? Because if you see this process right here, number has been reduced to 0. That's why here, when the expected value is 54, it returns 0, because the array list of integer right here is a list of 0 instead of 18 and 36 as expected. So we're going to change this to nums_i and run it again, and we'll try to submit it. And we're able to pass all of the test cases, which is good. So thank you for tuning in, and hope that you have a better understanding of this question, and I'll see you guys next time.